All right, so just real quick reminder that we talked about that normal condition that we talked about yesterday that said, under what circumstances will that distribution of x bars be approximately normal, okay? And the goal for these x bars being approximately normal, well, if my sample size is big enough, we don't need to worry about the population at all, okay? If our sample size is kind of what I would call mid-size, like between 15 and 30, okay? If that's the case, the population doesn't need to be perfectly normal. The x bars could still be normal as long as it's not majorly skewed or outliers, okay? If I have a really small sample, like smaller than 15, not only does my population need to be like have no major skewness, it needs to be mostly mound-shaped, okay? So that normal condition, so what that basically means, if my sample size is greater than or equal to 30, I don't have to do anything other than state that my sample size is greater than or equal to 30. If my sample size is in between 15 and 30, okay, then I need no major skewness or outliers. And what I'm going to do is draw a graph of my sample. And I'm going to look at it. Okay, that graph could be, for this one, it could be a box plot. So I could just real quick throw the data in my calculator and do a box plot. Or a dot plot, the box plot would be quicker, okay? Because all I have to show is no major skewness or outliers. If my sample is smaller than 15, I need my sample to be mound-shaped. I need to, so basically, in between 15 and 30, even if my population is slightly skewed, it's not a huge problem because the x bars will still be normal, okay? But if my sample size is smaller than 15, even a little bit of skewness is a problem for the x bars. That's kind of the thinking here. So everybody okay? All right. That being said, this is typically a good enough excuse. Typically, okay? So let's work an example because we have the basic structures at this point now. So would like to, this is a, so like a high-res screen, you can even you can kind of see it, when you stare at screens, you can see there's a netting or a mesh that kind of helps hold the screen and do the resolution, okay? And so each of that screen has a tension in between. That's what these numbers are supposed to represent, is the tension of these screens, okay? All right, and so we have this, so here we have our sample, and we're trying to figure out what is the mean tension, which is measured in millivolts, okay, of our screen. Everybody good? So this is 343 millivolts, 310 millivolts, etc. So the first thing we want to ask ourselves is, should we be doing a z interval or a t interval from mu? How do I make that decision? I say, do I know the standard deviation of my population? Do we? We don't have that. It's not given to us, and all we have is the sample. Now, can we find the mean and the standard deviation of the sample? Sure. So we can find the sample standard deviation. If I'm using the sample standard deviation, which, by the way, you will always really be using, okay, what procedure do we need to use? Well, we have one sample. We're going to do a t interval. And this time we're going to do it, I can spell interval. No longer are we going to do this for p, we're going to do it for mu. After I state my procedure, in the past I've always done, mu equals the true mean screen tension. I just added all right, next thing we're going to do is check our procedures. What's the first procedure we need to check? Random. And is this random sample? Hey, look at that. I just counted them. There's 14 of them, so can we use the sample size to call these normal? So what we have to do, draw some sort of graph, and again, relatively small sample, so not only do I need to show that it's not skewed, I actually have to show this pretty close to symmetric and mound shaped. Okay, so I put these in order? No, I didn't put these. What's the lowest one seem to be? 265 and 343. So if I have this go from 350 to 450, or I'm sorry, 250 to 350, or am I missing one? 234. Thank you. If I had this go then from like say 230 to 350, would that work? Okay, so I'm going to count by 20s. And for small samples, the dot plot, to me, makes the most sense. Everybody good? So, let's see. 270. 297. 270. 283. 305. 280. Does everybody see where these are coming from? I missed a couple, so 280. How are we feeling on pretty mound shaped and symmetric? Okay. So you're going to say, oh, we've got mound shaped, symmetric. So X bars can be assumed to be normal. And of course, we'll never say normal. We're going to say approximately normal. Independent. For manufacturer, you're going to hope that 14 is less than 10% of the screens that they produce in a day. All right, the next thing we need to do is run our interval, right? Okay, so we're up to the calculation point. So in order to run the interval, guys, what we're going to need to do is put our data into, if all we have is the raw data, you go ahead and put that into L1. Okay, so just a reminder, because it actually has been a hot minute since we've had to put stuff in the calculator. You hit stat and then hit edit. Those of you at home, pause the video and put the data into your L1. Okay? Everybody good? Everybody got it in? All right, so we're going to find the shortcut to the T interval in the same place where we found all the shortcuts to the Z stuff. Okay, so you're going to hit stat. You're going to arrow, once your calculator has the information, you're going to stat, arrow over to test. We want to choose the one sample T interval. That's the one labeled T interval. Okay, so you're going to pick option 8. And the first thing you're going to notice is they give you the option, do you want to do this from a list of data, or do you want to do it from summary statistics? In this case, what we have is the raw data. So you want to make sure it says, hey, highlight the data. And then it says, where did you store that data? We all put it in our L1, so it should say L1. Okay? That frequency you're always going to keep as a 1. It's saying each item occurred exactly one time. Each item in that list. Okay? And then this case we're doing a confidence level, a 90% confidence. So I'm going to change my confidence level to 0.9. And then I hit calculate. Before I hit calculate, have I communicated that I chose a T interval? Have I communicated the 90%? Not in my writing yet. So I'm going to go back over here and I'm going to say, oh, you guys, this was a 90% one sample T interval. Ever good? Like your rule of thumb is as you pick it or put it into the calculator, you're communicating it using the proper name, not the calculator name. Everybody good? Did you notice I didn't just put T interval, I said a 90% one sample T interval for, and then what I'm doing that interval for, okay? Now, when I hit calculate, it spits out a whole bunch of information. If it's important enough for you to put it in, you need to tell me. And if it's important enough for it to tell you, you need to tell me. Cool? So we're going to go X bar equals 290.5. Did we all get the same answer? I didn't put it in wrong? Okay. S equals 30.07. N equals 14. And my interval goes from 276.27 to 304.73. Are we seeing that once you know Z intervals, T intervals go really quickly, right? The procedure, like you guys have done the hard work for Unit 7 and Unit 6. It's just a matter of learning some of these new things. Okay? All right. Would anybody like to take a try at how I'm going to start my conclusion? We are 90% confident. The interval from notice I'm including units because now I have units. Like proportions don't necessarily have a unit the way means might. Now, do I know anything about electrical currents or what a millivolt is? I don't. I promise you, I'm very dumb when it comes to electricity. Okay? But I can still steal the units from the question. And what were we trying to estimate again? The true mean screen tension. We feeling okay? Anything you guys want to talk about? Let me see what the next example looks like. And if it's a hard one, I'll wait till tomorrow. Now we're going to do this one. It'll be quick, I promise. It's actually not going to get much quicker than this one, I promise, okay? All right, so I'll let you guys go ahead and read this real quick. You guys, I took a question out and I should have erased this part. Like I rewrote this question from a previous example, so I'm going to kick that out. All right. Are we getting a feel for some stuff here? What's the first thing that's jumping out at you guys? So we have a mean. And when we talk through that standard deviation, so we have x bar equals 66.8. And when we talk about that standard deviation, is that the standard deviation of a sample or of the sample or of the population? Sample. So it's an S equals 1.23. And we got one other thing I might write down in that little calculations area. Say it like you mean it. We know that my sample size is 40, which I'm hoping makes us all kind of happy, right? Like, because we all know what that means. All right, so cool. Hey guys, what am I going to do in the first box? A 95% one sample T interval for mu, which is the true mean mileage of the battery. Do you guys know what the solar panels we had installed were debating buying one of these like plug-in hybrids, which inspired me to write this question. Because like I drive 2 miles to get here. I would like never use gas for the plug-in hybrid unless I was going somewhere else, you know? I have to be going pretty far away. How are we feeling? Good? Okay, great. And next, random. Ooh. Okay, you guys. As often happens when Miss Meister writes a new example instead of pulling from an old one, she forgot the word random. It is okay to write must assume. If the College Board doesn't give it to you, they're not telling you don't run the test. Okay? So worst case scenario, right, must assume. Sometimes we say we're going to proceed with caution. Okay? But in reality, I left it out of the example when I wrote it. Okay? Now, I'm not telling you that the College Board won't give you a question where the procedures aren't or where the conditions are intentionally unmet. But when they do that, they don't say construct and interpret in an interval. They'll give you, it'll be like a part A, part B, part C question, and they'll say, explain why it would be unwise to move forward with a interval. And that's, so like, it's not that they'll never give you one where the conditions aren't met, but if they do, and it's done intentionally, they're going to ask you why you shouldn't. And if they ask you, why shouldn't you move on with this? Shouldn't that be like a hint to you? I'm going to go check my conditions and make sure my conditions are met. Yeah.
Let's be on the test.
Man, I wrote the test 2 weeks ago, so I don't know. And I haven't made up my answer key to the test yet. So I really, really don't know. Because I wrote it 2 weeks ago and haven't answered any of the questions on it. Are we good? All right. Normal. You guys, this is the best normal condition ever. N equals 40, which is greater than or equal to 30. X bars are approximately normal. Done. Independent. 40 is less than 10% of engines of this type. It's reasonable to assume a company is making more than 400 cars, of any car that they're making. Okay. Next. Let's get that interval by going into our calculator and doing so. Come on. So I'm going to, again, hit stat, arrow over to tests. Choose the T interval, which is option 8. This time, do I have the data? No, I can't type this stuff into L1. So instead, what I have are summary statistics, so I'm going to go over and highlight the statistics. What do you think I should put in for X bar, y'all? And, oh, come on. And for my standard deviation, 1.23. For my sample size, 40. My confidence level, 0.95. Calculate. All right, let's interpret that interval. We're 95% confident the interval from 66.41 miles to 67.19 miles contains the true mean mileage of the engine. Does this feel reasonable? All right, now, the company needs them to be doing better than 66 miles. Or I'm sorry, 65 miles, right? They need to last 65 miles. So how they doing, okay? What about this interval suggests that they are doing better than 65 miles? The whole interval's above 65, so we're good. Done. That seems like a great place to stop, unless you guys are bored and want to do another example.